HVAC 360, episode number 53, Building Energy Efficiency. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. This week, we're going to talk to Chris Mathis of Mathis Consulting. Chris is a distinguished lecturer in ASHRAE, and he has a lot of good information about building efficiency and the building science. One of his more popular topics, which we're going to kind of get into a little bit later in the interview, is his fascination with the Honeybee. So it's kind of a different take on it, but if you really start to analyze it and look at it, it's really a fun way and a kind of a reality check when you take a look at building science and how sustainability should integrate into the whole building process. So without further ado, let's cut to the tape with Chris Mathis. All right, today we're going to be talking with Chris Mathis, who is the president of Mathis Consulting. How are you doing today, Chris?
I'm doing great.
Hey, so tell me a little bit about how you got into the building industry.
Well, Matt, I'm the luckiest guy you know. I have had the incredible good fortune of, when I got out of college, I wasn't quite sure what I wanted to do. It was, and I was looking at the sciences, looking at the arts, and trying to find a way to make a difference. And it was in the height of the passive solar, no nuke, save the whales era. And so I went to graduate school focusing on building energy performance. And I have been blessed to be able to work in that area of building energy efficiency for now over 30 years. It's been in a variety of capacities, working for manufacturer-related research, working in test laboratories, working for nonprofits, doing some government research projects. We're in a lot of different areas, focusing on products, focusing on whole building performance. And I learned that one of my kind of responsibilities, I guess, is to share some of that information that I've learned in my 30-plus years in this industry. And that's why I was really excited about this interview today, so we can talk about buildings and building performance and why they're important, and really focus on energy efficiency.
Now, what is your firm, Mathis Consulting? What is that? What is the focus of your firm?
We do a lot of different things, from building forensics investigations, why buildings fail, what are the problems there, to helping both at the state and national level understand and develop new building codes and energy codes to help constantly improve our buildings. We do some lots of training. We travel around the country talking to architects, engineers, building developers, builders, owners on how the building code works, what the energy code requires, how to do better than the energy code. If we're trying to do green and sustainable things, how do you accomplish those green and sustainable things? And most recently, we've been doing a lot of training for our nation's building inspectors. And that has just been such a joy, because our building officials, a lot of times we'll just develop a new code and then we kind of toss it over the sound screen to the building officials and say, now you guys go do this new code. And we haven't necessarily given them all of the tools that they need to help us accomplish the objectives that are laid out in the code, especially with regard to energy efficiency. We do pretty good on, like fire safety and all of that sort of stuff. But in this area of energy, our building officials right now have a heightened awareness about it, because, let's face it, they buy gas at the same gas station we do. They buy milk at the same grocery stores we do. And they're really critical partners in helping to make sure that our buildings perform. So that training of our building officials to make sure that we actually get that energy performance on the ground has been really a key part of our work in the past few years.
So, taking a broad brush approach to it, what is your view on building energy efficiency?
Well, I believe that improving the energy efficiency of our nation's buildings is probably the single most important thing that we should be doing as a society right now. I believe that we failed. We as architects and engineers have failed to let people know just how important our buildings are. Buildings are our number one energy user. 70% of our electricity demand goes to buildings. They're responsible for more atmospheric pollution than all of the cars and all of industry. It's our buildings. Our buildings are our big energy hogs. And we've really not let people know just how important they are. And the challenge of that is that it's a big honking concept. People don't think about our buildings in that context. People don't think about their home being responsible for twice as much pollution as their car because of the energy demand of our buildings. And while our codes address new construction fairly well, we're doing a pretty good job with new construction. That's only 1 or 2% of our building stock in any given year. So there's this big gorilla in the corner called our existing buildings, 120 million residential buildings and similar numbers of commercial buildings. It's like this big, hungry gorilla in the corner that's eating our energy lunch. The good news is we've got all the stuff we need to make all of those buildings better. We've got the manufacturing, the products, the tools, the know-how, the expertise. We just haven't made it a priority. We haven't fixed our buildings fast enough, big enough scale. We haven't reduced their energy demand and consumption. And there's lots of socio-political implications to it, which is not the topic for this conversation today. But I will say that if we were to put our focus on fixing our buildings, we'd put more people to work. We'd put them to work here at home. We'd create long-lasting, durable jobs and save more energy, reduce our reliance on foreign energy supplies, clean the air, clean the water, and that, those are just kind of the big, broad paintbrush issues that we go into in some more detail in some of our classes. But that's the thing. It's about our buildings, and it's about their insatiable appetite for energy. All you have to do to get a perspective on this is think about how many big screen TVs did you have at home 10 years ago? How about that laptop charger, that extra cell phone charger, and the computer, and the Wii, and the Nintendo, and all of those other things that are plugged in at home right now? We have an insatiable appetite for electricity, and it shows really no sign of abating. And we've got to make our buildings more energy efficient if we're going to feed that beast and keep it at bay in terms of our limited energy supply.
I know. I feel guilty right now. I look at a number of things, from even just as simple as like a pencil sharpener around, sitting around, and everything's just kind of always on, waiting for me to pay attention to it and use it. But yet, it's still just sitting there, consuming energy.
Well, and there are lots of those unintended consequences too. For example, there's a rather famous story of a LEED award-winning energy efficient building. And when they started measuring the energy use, they found that it was using more energy than allowed by code. And they go, now, wait a minute. We had the best architect, the best engineers. They checked everything. They commissioned the equipment, the lighting system. They commissioned the envelope. They did air sealing testing, and everything looked great. How could this building be using more energy? And it was one of those, multi-story office buildings with miles and miles of cubicles. And as they started walking through each floor, what they found in each cubicle was the personal refrigerator, the personal microwave, the personal coffee pot, the personal desk lamp, the under-the-desk space heater, the desk fan, the extra cell phone charger, the extra laptop charger, and they had like 3 times the plug loads. Everybody had their own little personal kitchen and electrical animal in their little cubicle. And not only did they have those little kitchens in each of their cubicles, the actual kitchen on each floor was like 50 feet away. So, we've got to become much more aware of those unintended consequences.
So it's more of a social thing that we as a society need to kind of re-educate ourselves on, what really we should be using. Yeah,
the problem, Matt, is building energy performance is out of sight, out of mind. We don't think about our house polluting twice as much as our cars because our cars have exhaust pipes. The house doesn't. The house's exhaust pipes, if you will, are down at the local utility. So we don't get very efficient messaging on building energy performance. We get a rather inefficient one. We get an electric bill or a gas bill or an energy bill once a month. Well, that's really not an efficient signal for response. Now, compare that to going to the gas station. You get a really efficient price signal there every time you fill up. So I've been saying for some time, wow, wouldn't it be better if our light switches read off in dollars? Or every time we plug that cell phone charger in, that little brick read off in dollars. If we started getting signals about energy use that were much more efficiently delivered, we might be much more aware as a society of those, of the role of our buildings and the importance of building energy efficiency. Think about it this way. We go to the thermostat and go, man, I'm a little hot. I'm going to turn that air conditioning down to a couple of degrees, maybe put it down to like 72, which seems to be really common throughout the country. A 2-degree change on the thermostat doesn't seem like a big deal, but it can overwhelm just about every other efficiency decision that we might have made for that building. So one of the things that we've got to do is get that building envelope right from the start. It's got to be really good so that the building is more isolated, insulated, and protected from those big temperature extremes. The trouble with our thermostats, they don't read off in dollars. The trouble with our electric meters, they don't read off in dollars. So we've not done a good job of giving the people that own and occupy and run and manage buildings, whether residential or commercial, we haven't given them efficient signals on what it really costs. And not what it just costs to their pocketbook, but then what does it cost in terms of water consumption, clean air, energy security, and all those other bigger issues.
So now, talking about costs, when you apply that to new buildings, that seems to be, just a sensible thing that you can build a cheaper building that's less a less efficient building that's really cheap, but it's expensive to build a high efficiency building. What's your reaction to that?
Well, one of the things that we have to think about as a society, that again, another thing that we don't think about is how long these decisions last. What the average age of a house in America is right now, it's like 80 to 100 years. So we're making decisions about buildings that are going to be around, often more than 100 years. And even if it's only going to be around for 50 to 100 years, we've got to start thinking about, wait a minute, that little bit of extra insulation, that little better window, that little better attention to air sealing and details, that's a decision that's going to impact us for 100 years. We get so caught up in these first cost decisions, I got to do it fast and cheap, that we end up paying forever. We did a study recently for North and South Carolina where we were looking at the cost to increase the energy efficiency in a typical home. And we looked at starter homes. And let's remember that a home is typically the single largest purchase that an American family ever makes. It's like defines the American dream. And, we looked at what it would take to go to the latest version of the model energy code. Now, let's remember what the code defines. The code defines the least strong, least safe, least energy efficient building allowed by law. Okay? In other words, we can't build it any crap here. The code is the bottom. It's not the best. It's the starting point for then showing how we can do better. And we looked at what it would take to just update to the latest version of the International Energy Conservation Code. And the numbers were startling. On the front end, it looked like it was going to cost a builder about $1,200 additional dollars. And, of course, that sends up all sorts of red flags. Oh, no, we can't afford that. That's terrible. The sky is going to fall. But then when we start looking at the implications for that homeowner, we find out, oh, wait a minute, it's going to cost $1,200. That's about $13 a month on a 30-year mortgage. And it's going to save $30 to $50 a month in energy bills. So let's see, cost $13, saves $50. Cost $13, saves $50. It just seemed like such a no-brainer. So what we find ourselves doing is working with builders sometimes to say, look, you want to make that investment in that $1,200 because, number one, you're going to mark it up, make profit, and your buildings are going to be more desirable because they're better and have lower operating costs. The people, you're going to qualify more people for your buildings rather than the guy down the street who's building to an antiquated energy standard. And then what are people going to do with the savings? Well, one of the things that we've got to remember is that energy inflation is regressive in the extreme. It hurts poor people first and worse. When we look at the demographics, we find that the average American spends about 4% of their income on energy. The people that are at or below the poverty level spend 18 to 20% of their income on energy. So when we save energy for those of our society that are least able to be wasteful, several really interesting things happen. First of all, in-home nutrition goes up. Now, how many HVAC contractors and architects and designers and builders are thinking about, if I make this building more energy efficient, their children are going to have better food. We don't make those big social connections sometimes. But, those decisions that we're making, and the example I just cited was about homes, but the same math applies in the commercial environment. We're building a building that's going to be around for how long? 50 years. It's going to be consuming energy. It's going to be asking for those natural resources, the energy resources, the hydrocarbons, the kilowatts, the BTUs for 50 or 100 years. We've got to start looking at those investments in energy efficiency in terms of that building's life cycle, not just in terms of its first cost. And, we all did this back in college when we had those economics classes, and they taught us how to do these simple life cycle assessments. Well, that's really the fundamental underpinning of all of the discussion of green buildings and sustainability. It's all about this question of energy efficient, durable, and safe for how long? And that time variable in the equation changes everybody's economics, changes how we decide to make those investments.
So ultimately, when we take a look at, who's making these decisions, really, is it, I mean, the fault of the architect, the fault of the general contractor, the builder, who should be stepping up and taking more of a leadership role to make sure that these things happen? I mean, is the engineer or what?
Well, there's certainly a role for all of the people that you mentioned, and one of the problems is that we've gotten so compartmentalized. You just mentioned the architect, the engineer, the general contractor, and the HVAC guy. Well, if they're all operating in their little silos and not working together toward a common goal and objective, then we'll never get there. One of the key messages in the various classes and trainings that we do around the country is, break out of your silo. If I'm talking to a bunch of engineers, I'll say, did you invite your local architects to this same meeting this evening? And if I get to them in advance, I'll say, I'm not going to come and talk to you until you get the opposition in the room, the architects in the room, or the contractors in the room. When I go and talk to building officials, I'll say, grab your favorite builder and bring him with you. Grab your favorite HVAC contractor and bring him with you, so that we're all hearing the same message, because guess what? At the end of the day, we're all in this together. It used to be, in the old days, that the architect was the engineer and the contractor and did material selection and did everything, okay? And as we've kind of reduced everybody's levels of responsibility, it's real easy for people to say, well, that's not my job. Oh, that's a leaky building envelope. Well, I'm just the HVAC contractor. That's not my job. I'll just put in a bigger fan. Or, that HVAC system wasn't installed right, but I just did the design on the outside, so that's not my job. It's really easy for people to say that's not my job. One of the things that I've been doing with people lately is when they're making these decisions, I get them to add a little phrase to the end of that decision. And that phrase is, for about 100 years. When they are saying, well, I'm not going to put in that little bit of extra insulation. That's not my job. So we're going to, that's good enough. I then have them say, for about 100 years. It puts a different context around how important our buildings are.
Now, is it more important to, in your opinion, is it more important to focus on the building and the building envelope rather than trying to get a more advanced, more efficiency out of the HVAC system?
Well, I will tell you that we'll put in 4, 5, 6 different HVAC and lighting systems over the life of the building. But generally, we get one shot at the envelope. Very rarely will we rip a facade off and improve a building envelope. So I like to say, it's like that old ad from the 60s. You never get a second chance to make a first impression. That building envelope is going to be with that building likely for its useful life, whether that life's 50 years, 75 years, 100 years. So, boy, we better get that one right. And what I tell, the HVAC community is that if we're working with an architect or a designer or that's focusing on this building envelope, we should be encouraging them to make the best possible building envelope they possibly can so that we can put in the smallest, best efficient, best operating, most highly controlled HVAC system that we can. We used to always think that bigger is better. Bigger is better. Bigger is better. Well, with regard to building energy efficiency, smaller is better. Smaller is better controlled, more responsive, rapid turnaround, more efficient. We did a project down in Texas where a house was instrumented with all this state acquisition stuff, and we were checking the loads and everything, and it was a standard 2-zone system. It had a 2-ton unit and a 4-ton unit. And we get back to the office, and the data's not coming in on the 2-ton unit. And we go and have the HVAC guy check it, the charge is right, everything's working right, and the 2-ton unit never turned on. And so we went to the guy who did the sizing calc. He says, I've been doing Joe's houses for 20 years. He always gets 6 tons. Well, what this guy didn't realize is that we had changed the windows, and we had cut the cooling load in half just by changing the windows. So Joe didn't need 6 tons anymore. He actually needed about 3.5 tons. So here's an example where that builder needed to sit down with his HVAC contractor and say, by the way, I've changed my windows to these new windows that reduce my solar gain. And I did this in conjunction with the architect, and this new state code that's coming out, and you need to be aware. Well, here's a case where the poor HVAC guys have been doing a great job for 20 years, didn't know that the load had just been cut in half. So whose fault is it? Well, it's the fault of communication. We needed to get all those people on the same page. And we need to do that for every building, not just new construction, but on existing buildings too. If you got a facilities manager who's just challenged, and dealing with complaints all the time and trying to keep the building operating, we've got to help him. We've got to let that building owner have a higher level of understanding and more highly prioritized building energy efficiency. One of the things that we're seeing these days is some of these green and sustainable and super energy efficient buildings, they're actually bringing in higher per square footage rental revenues. So it's like people are going, that's super energy efficient. That's a higher valued space, and they're actually being able to bring in more money. So there's, again, we've got to teach more people about this importance of building performance. To wrap up on that particular question, I believe we got to get the building envelope right. You've got a limited number of variables, okay? You've got the opaque portion, the roof, the wall, the floor, the below-grade parts, the stuff that we insulate. Boy, let's get that right. You've got the fenestration portion. You've got the windows. And fortunately, the window industry's done a lot of really cool innovations. We've got dramatically better windows than we used to have. And then you've got air leakage. So you really only got, kind of 3 big variables at the building envelope. Insulation, better windows, better air sealing. The trouble with having a conversation with people about insulation and windows and air sealing is, and lots of this stuff about energy efficiency, even duct insulation and duct sealing and all of that stuff, the trouble with energy efficiency is it's just boring. It is boring. It's hard to get people excited about insulation and caulk and pookie and weather strip and duct mastic. People would much rather spend their thought time on, the sexy new stuff, the solar thermal and solar PV and methane vehicles, methane recovery from landfill hybrid vehicles and stuff like that. The energy efficiency, by comparison, is boring. It is dramatically more powerful than all of those other variables that I mentioned. I describe our buildings, our buildings are responsible for half of our nation's energy use, roughly speaking, half. And I describe it as this big ship. It's a ship full of holes. And we're so busy putting really sexy stuff up on the deck of the ship, photovoltaics and hybrid vehicles and all that stuff, that we forgot to plug the holes in the ship. Now, we've got all the stuff to plug the holes in the ship, like duct mastic, ducts are leaky. Ducts are leaky everywhere. And we've failed to communicate clearly just how important and how powerful that boring stuff really is.
So now tell me, if anybody who's visited your website or has heard you lecture has heard you talk about your honeybees. So tell us about the fascination with honeybees.
Well, I had been doing building science for about 30 years, and I moved back to the mountains of western North Carolina where I grew up, and I wanted to take up, a hobby or something that would kind of give me a break from building science. I'd been doing the building science thing, loved it, and still do the building science thing, but I needed kind of something to get me maybe, a little closer to nature, get back on the farm here a little bit. And my grandfather had honeybees when I was growing up, and we had a couple of hives for a while. And when I got back to the mountains of North Carolina, my uncle had some honeybees, and I thought, well, I'll help him out a little bit. One thing led to another, and got really into it, became fascinated by it. And, well, it turns out the joke was on me. Here I wanted a break from building science, and it turns out that our honeybees are among some of the most amazing building scientists on the planet. I really got into it and started doing some research on my own and got to know the head guy at our local state university that did a lot of honeybee research. And one thing led to another. I ended up writing an H3 paper on building science lessons of the honeybee, and it turns out it's one of my more requested talks. To put it in perspective for you, the honeybee, they've been around, 70 or 80 million years longer than we have. And so they've probably experienced more climate change than we'll ever imagine and challenges. But they have this incredible built environment. They build these structures, they control the temperature and the relative humidity, and they actively ventilate, and they control the indoor air quality, and they do all of this stuff that we do with buildings. For example, the brood nest of a beehive where they raise their young, they control to 93 plus or minus 2 degrees Fahrenheit. Whether it's 0 outside or 100 outside. Now, we have a hard time doing that with the thermostat, and they do it biologically. So the more I got into beekeeping, and I became a beekeeping educator as well, and I teach introductory beekeeping fairly often. And then after I wrote this H3 paper, I've had the opportunity to give this talk in India and other places around the world, and it is really it's an engineering talk, it's an HVAC talk, it's a building science talk in many ways, but it's lessons that we might learn from nature. And sure, there are many other natural systems that we could similarly learn from. This one is just one that I was fortunate to to experience the irony of, I want to get away from building science for a little bit. Well, it gave me an escape, but certainly not an escape from building science. It gave me a lot of lessons in building science. And back to what we were talking about earlier, one of the key things is, honeybees don't build their structure, that incredible honeycomb structure, indiscriminately. They really put a lot of effort into it. And there are a lot of parallels in the class that I teach. We talk about a lot of those parallels between buildings and honeybees, but a lot of parallels in terms of how they make sure that they're protected and sealed and the structure is good and sound and appropriate use of resources and resource conservation and lots of great lessons.
Now, I've heard your talk on the honeybees, and I guess one of the things that kind of interested me was what the hive was made out of. And if something happens, that they end up recycling. Can you tell us a little bit more about that?
Well, most people have a visual familiarity with honeycomb. Honeycomb is one of the most intensely studied structures in science and nature. If you look, cut through the wing of the space shuttle, you would find a honeycomb structure. And if you look at what we're doing with nanotubes and nanoparticles right now in that research, again, it's a honeycomb structure. So this structure shows up a lot of places because of this incredible strength-to-weight ratio. The honeybees make their honeycomb by extracting this wax from a gland in their abdomen, and it is very energy intensive. You can think about it this way. It's very high first cost. It takes a lot of energy for them to make that wax, form that wax, and make that incredible honeycomb. It is so energy intensive that they don't do that indiscriminately. They're very careful to make it, shape it, and protect it in such a way that they're getting the maximum utilization out of it. If a section of honeycomb gets damaged, they'll start the process of actually making more honeycomb, but they'll actually, if they need to, move wax from other areas of the hive to repair the damaged section. So they really put a lot of emphasis on building it right the first time. Now, one of the lessons that we take from that is, okay, building it right the first time, and not being wasteful. Let's use an example, say in residential construction. You can build out of 2x4s, 16 inches on center, or 2x6s, 2 feet on center. If I see a builder and I say to him, hey, I know that you're building out of 2x4s, 16 inches on center. We learned back in 1885 in the Wood Handbook that if you built out of 2x6s, 2 feet on center, that you could build a stronger wall with less material, lower first cost, better insulated, with less waste, more profitably. Now, I just listed 6 reasons to go to a 2x6 wall, 2 feet on center. But I asked that builder to do the one thing that none of us like to do, and that's change. Mm-hmm. Change makes us all uncomfortable, even when it's change in our own best interest. Now, if I'm talking one-on-one with the builder and I show him this, and we go through the learning curve together, once he figures out how to do that 2x6 framing, he never goes back, because it's such a better way to build, so much more resource efficient, stronger wall, better insulated, more profitable, and he has to go through that learning curve. Once he does that, he's a convert. asking people to change the way they build building envelopes is a big honking challenge. Take commercial curtain wall systems. You know, the advent of the curtain wall, aluminum extrusion, and glass have changed the face of urban America. And we could hang these relatively lightweight skins onto the structural components of the building and make all of these phenomenal architectural statements. Glass is one of those amazing materials. It makes these wonderful architectural statements. The trouble is, if we don't make that skin energy efficient at the same time we're making those architectural statements, then we've put up that skin that's going to be there for about 100 years, or about 50 years, or about 75 years. Again, adding that little phrase onto those decision sentences is a really good litmus test of the rationality of those decisions.
Yeah, you bring up an interesting point, if I can interject there, that, you know, if you take a look at a beehive, you know, you have no windows. I mean, there's basically, you have an entrance, you know, to the beehive, and that's about it. If you take a look at maybe sort of like primitive houses, it was always those window openings were kind of premiums, and now we're taking the standpoint that we're making entire, you know, giant structures out of this glass, and, you know, I mean, frankly, I have a love-hate relationship with it because I think it looks cool, but at the same point, I'm like, you know, the solar gain from that skin is just killing everybody. What's the balance there? I mean,
well, you bring up a good point, and let's go down this rabbit hole just a little bit. First of all, a natural beehive in nature was a hole in a hollow tree, okay, and that tree was, you know, wood and a fairly good insulator, and the bees would sometimes, you know, make the hole smaller so that they would be more protected from the elements. So there was a recognition and a responsibility to microclimate there. Now, I have to tell you, I love glass. I spent a good chunk of my professional career helping to develop the rating and labeling system for the energy performance of fenestration. And you know, I've often said the window industry has a really tough job because, you know, their job in many ways is selling the invisible. You know, it's like you look at it and does it have one pane of glass or two? Well, you can visually inspect that, okay? But does it have a low E coating? I don't know. It's invisible. Does it have gas fill, argon or krypton or any of that stuff? Well, I don't know. It's invisible. You know, is it a thermally improved frame? Well, once it's in place, I really can't look at it and tell. That's invisible. So they have, you know, the showing and demonstrating their energy performance has been a challenge because they're selling the invisible. Now, I can certainly respect the love-hate relationship on the HVAC side because we spend an awful lot of our HVAC energies trying to overcome really crappy glass decisions. Okay, we've while we've got an array of super energy efficient glazing systems available, for whatever reason, we're still putting up, you know, R2 glazing systems that are, it's just ridiculous, you know, and we've got thermally improved aluminum extrusions and fancy, you know, thermal breaks and that technology now that are available where we can get U factors down around, you know, 0.15, 0.17. I mean, really good U factors for something that I'm going to be looking through. Okay? So that's an area where we've got to more highly prioritize the building envelope. And that's an area of significant need for prioritization. Another area that's very important is just basic insulation levels. Well, we've done a pretty good job with new construction. But think about typical commercial buildings. First of all, we built most of the commercial buildings in America right after World War II. Okay, our soldiers came home from war, and from say 1950 to 1980, we built like 3/4 of the commercial buildings in America. But what do those commercial buildings all have in common? Well, they have little or no insulation in the roof, no insulation in the walls, single or double pane, crappy glass, steel or aluminum curtain walls that are highly conductive. They leak like sieves. Their building envelopes leak like sieves. They've got old or outdated HVAC systems, old lighting systems, bad ductwork that leaks like sieves. And you'd think that I was really saying negative things about all of those commercial buildings. But there are two things that those buildings have in common that trump all of those attributes that I just listed. First of all, most of those buildings have really good bones. We built them really well. Those bones are sitting there, and they've served us for 40 or 50 or 60 years now. And they're sitting there saying, I could serve you for another 40 or 50 or 60 years. What do we need to bring those good bones to their next 40 or 50 or 60 years of service? Well, we need lightweight insulation and finish systems that we can hang on those good bones. Well, we've got that. We need energy-efficient windows to replace those old crappy ones. Well, we've got those. We need goops and foams and pookies and sealants to plug all those holes in that building envelope. We've got that. They need roofing insulation. We've got that. They need energy-efficient HVAC systems. We've got those. They need ducts that are well insulated and well sealed and duct masking. We've got that. And they need energy-efficient lighting systems. We've got that. We've got everything we need to bring those buildings to their next 40, 50, 60 years of service to us. All made right here in America. Again, going back to that creating jobs, putting people to work, so on and so forth. We've got everything that we need. Now, there's one other variable that those buildings have in common that even trumps that one, the good bones variable.
What's that?
And that's location. These buildings are in downtown areas that we're trying to revitalize. They're in urban perimeters we're trying to make safe again. They're on existing roads and water and sewer and power. They've got all the infrastructure already there. They're on the way to work, on the way home, on the way to church, on the way to school. They're exactly where we need them to be. So we've got everything that we need to bring those buildings to their next 6 years of service life to us. We've got all the stuff. We make it all right here, and they're right where we need them to be. We've got to more highly prioritize our existing buildings, residential and commercial.
Mm-hmm. Yeah, I mean, essentially they were built kind of at the first choice. It's like, where's the best choice? Well, let's put them right here because it's really convenient, and we don't have cars or anything like that. It's kind of where it made sense. And then now we're kind of, it seems that most of the growth in the housing market and some of those other things are like what's left over. Okay, well, there's some farming land over here. Let's develop that, or here's an empty field, or here's a swamp. Let's just fill it in and try to make the best of it.
Well, this is one of the big challenges of the green building community right now, this whole sustainability movement, is we recognize that infrastructure costs a lot. If I'm going out here into a green field and doing a development, and I've got to build a road out to it, and I've got to bring power out to it, and water treatment and sewer and then parking and public transport and all of that sort of stuff, those are huge energy uses and demands. Whereas if I'm fixing an existing building that's already got all that other infrastructure stuff, I mean, think about the green and sustainability and carbon implications of fixing a building in an urban center versus greenfield development. It's just completely different scale of energy demand.
So I mean, obviously, there's so much sense that sustainability and reuse and getting back into existing buildings with good bones. Where's the train? I mean, shouldn't there be some sort of shouldn't it make economic sense to be able to just reuse or improve? I mean, where's the disconnect? Why aren't we getting to that sustainability, sustainable kind of movement? What's keeping a large majority? I mean, obviously there's some funding from the government that's taking place in the United States, to be able to improve energy efficiency. It seems that even like you talk European, I have this perception that they're really doing a lot more just because of government mandates. I mean, is that what it's going to take to make the economic switch that we're really got to tighten our belts through government legislation, or what?
You really are trying to back me into a political statement, aren't you? Okay, all right. I'll rise to the bait. Here's the thing. We've got to prioritize our buildings more. And it's going to require both push forces and pull forces. It's going to require push forces like codes and laws and regulations and those things, because the market itself isn't efficient. We have to have a balance of push and pull forces. And it's going to take pull forces, too. We're going to have to make it worth people's while to invest in their homes and in their commercial buildings and in our new buildings as well. We're going to have to do it with things like utility programs. We're already starting to see a lot of that around the country, where our utilities are getting re-engaged in building energy efficiency more than they ever have. We're going to see things like tax incentives and rebates and homeowner incentives and things like that. We're going to have those pull forces as well. It's going to take a balance of those things. That's why we spend a lot of time talking about the code and improving the code, and at the same time we spend a lot of time talking about, now here's how we should get a utility to invest. One of the things that we don't think about with regard to our buildings, and again, this is one of the failures of those of us in the buildings and HVAC and efficiency arena, one of our biggest failures is that we've neglected to talk about the implications of these building decisions on our nation's utilities. Think about the I-95 corridor, for example, from Miami to Maine. What do? Every morning we get up, we shower, we shave, we cook breakfast, we start asking for more energy. Then we get to the office and we turn on the elevators and the escalators and the lights and the copiers and the computers and the coffee pot, and we start air conditioning all those buildings. And by the time 10, 11 o'clock rolls around, especially in the heat of summer, we're asking our utilities to give us all they've got. And, it's all driven by air conditioning and lighting. I mean, our utilities loads are dominated by buildings. And we're turning all of our buildings on, and asking for all this power at the same time. So part of our problem is not just an energy problem, it's an energy timing problem. It's a power problem that we want it at a certain time. So we have to be much more cognizant of this interconnection between utility policy and building policy. In my home state of North Carolina, we've got a building code council that helps shape the state's building codes, and across town you've got the utility commission, which helps shape the state's energy supply, for the foreseeable future. And unfortunately, those two groups that are intricately and intimately linked don't even talk to each other. They don't even know that the decisions made in one room have this huge and lasting impact to the decisions made in the other room. So one of the things we're trying to do is to reconnect utility decision makers with building regulation decision makers. Huge need there for a conversation or two to be had. Back in the late 70s, early 80s, the number one purchaser of insulation in America was our nation's utilities. Now, they didn't go down to Lowe's and Home Depot and buy insulation. No, they wrote homeowners checks for adding insulation to their attics and to their walls and to their basements. And those $200 and $300 and $400 checks had the effect of having our insulation industry running 24/7, 365, cranking out as much as they could make. Because it was cheaper to insulate than it was to buy that limited amount of fuel from OPEC nations. Well, we're starting to see that trend again, where our utilities are saying, I want to help make better building decisions. I want to help because it's easier to insulate a building and change the windows and seal up the ductwork than it is to build that new power plant. So we've got to make it more profitable for our utilities to be able to invest bigger and better in our buildings. And some of the more forward-thinking utilities around the country have already made that transition and are now a major player in building energy performance. I've seen utilities right now that are carrying on their books energy conservation, energy efficiency, improved energy efficiency as a resource, where they're showing 20% of their load is going to be met by investing in efficiency. So that's one of those areas where the architect, the engineer, the HVAC contractor, they may not be thinking about the fact that their partner in those building decisions is the local utility. And hopefully that dialogue is going to gain a lot of momentum.
Now, as far as training and education, I mean, obviously, I think if you listen to everything that we're talking about, there's a lot of opportunity out there that's for whether it be existing buildings and whether it be for a contractor, architect, engineer. I guess what should people focus on, or even I guess what should professionals? We'll take it in a two-part. What should professionals in the building industry focus on as far as training goes? And what if somebody that's going to college? What should they pick a major? Should they what should they do to make sure that they're well educated on the building sciences and what the opportunities out there?
Well, I'm going to answer that question two ways. The first thing I'm going to say is, if you're going to stick with business as usual, you're going to fail. It's that kind of dinosaur mentality. Remember, when times get tough, one of the things that people do by nature is they retreat to the devil they know. They retreat to the engineering practice they know, the architectural practice they know. They stick with the status quo. And if ever there was a time that change was needed, really dramatic change was needed, it's when times get tough. So the more we start to hurt should cause us to say, what could I do different? What could I do better? How should we change to address this tough time? I mean, look at it. When gas went to $4 a gallon, we all changed our driving habits. Instead of going to the grocery store twice a week, we went once. Or instead of once a week, we went every other week. I mean, people will respond to those signals. So one of the things that we're going to have to do is change. That change is going to require that we value our buildings more and that we start getting more efficient signals on just what the real cost of those energy decisions are. The second part of the answer here is you hit the nail firmly on the head. It's education. We expect, young engineers coming out of college to be able to do all of this fancy math and do, maybe they had some HVAC training, maybe they understand the fundamentals of load calcs, but they don't necessarily know anything about buildings. And these building decisions are going to be around for about 100 years. So we've got to much more heavily invest in the education of everybody that touches a building. That from on the commercial side, it's not just the architect and the engineer. It's that guy on the ground who's trying to do the air sealing of the envelope, and we've got to let him know and understand just how important that decision is, and what he does matters for the life of that building. We've got to, when we put in ductwork, it's got to be well designed and well sealed and well insulated. And when we're sizing those systems, we all do shortcuts. And it's the one area where we shouldn't be doing a shortcut. We've got to get those systems sized properly, not oversized, but appropriately sized. And if an engineer sees, a really bad architectural decision because they actually know about buildings and understand building performance, they need to understand that, hey, we're in this together. If you were to improve that roof insulation a little bit, I could step down this furnace size by so many 100,000 BTUs. Or if you were to pick a better window, I could cut my cooling capacity in half. We've got to understand that we're all in this together. And that's going to take a real serious investment in education. And I guess there is a third part of this is we got to broaden the reach of our education. Our utilities have done a great job providing power to America for a number of years. They've been doing it successfully. I mean, it's one of the best examples of what we can do when we set our minds to it. Make electricity for everybody. That's an amazing thing that we've accomplished. But now it's not so easy anymore. We can't just drill another well, dig more coal, build another nuclear plant, especially when we've got buildings, hundreds of thousands of buildings out there, millions of buildings that are out there, that if we were to fix them, we wouldn't need any new power plants. So we've got to expand the breadth of our conversation. We've got to get out of our comfort zone and not just talk to engineers if we're engineers, and not just talk to architects if we're architects, and not just talk to HVAC contractors. We've got to get everybody in the room. We've got to get that building official in the room. He cares. We've got to get that utility planner in the room. We've got to get that state legislator in the room. We need the local school board members to be in the rooms to understand that we need to fix our schools. We need to fix those buildings so that we're not being wasteful there. And then we need to make it really a high priority that people invest in their homes. They need to be able to invest in their homes aggressively, especially as it relates to improvements in energy efficiency, because it's going to be around for about 100 years. And we just can't afford to be wasteful anymore.
All right. Well, I appreciate you taking the time here to speak with us. I guess any last words, anything that we haven't touched as far as subjects go that you want to say something about?
Well, I guess I kind of said it in that last statement, in that we are all in this together. It's an increasingly small planet, and getting smaller every day. And if we've got to get our own house in order. And probably one of the most important things we could export is to tell and show the rest of the world how important buildings are, and that they need to be more durable, more safe, more efficient as well, and that we know how to do it. But we've got to get our own house in order first.
All right, great. Well, for anybody that wants more information, what's the best way to get in touch with you?
Our website is mathisconsulting.com, M-A-T-H-I-S consulting.com, and contact information is there on the site.
Great. All right. Well, I appreciate you taking the time, Chris, to talk with us regarding this subject. It's a subject that's near and dear to my heart. So I appreciate you taking the time.
Thanks for having me, Matt.
All right, and we're back. All right, I'd like to really extend a sincere thank you to Chris Mathis for taking the time to talk with us. I know the show is probably pretty long, so I will kind of cut everything short. If you have any suggestions, if you have any feedback, please let me know, matt@buildingx.co, or if you'd like to offer some other suggestions. Otherwise, if you want to connect with me, just contact me via LinkedIn, or if you do that Twitter thing, matt@buildingx at buildingx is the website. So if you want a newsletter, I send those out kind of erratically, but I do send them out so that you can sign up at the website www.buildingx.co, and that is about it. I appreciate each and every one of you. It's been really exciting to be able to do these things, these interviews for you. I hope you gain something out of them and find them educational. Again, we're just, we're trying to get that information to you guys because you are the leaders of the industry. You are the 3%, the very best of the best. So thank you for listening. I appreciate each and every one of you, and we will talk to you later. So remember, always know what you build and share what you know.